my name is Donna Dietz, and I teach in Washington, D.C. at American University. This talk is about a fun lab I've done now with 2 or 3 groups of introductory stats classes. I totally love it, and the students seem to like it too. I came up with this idea because I was looking for a way to get them to collect their own data on their phones in a meaningful but easy way, and I thought of having them use the GPS software on their phones. We think of this generation as being saturated in technology, but it's really quite amazing what they don't understand about their computers and their phones. And they really love it when you teach them something new they can do on their devices. Learning objectives you can meet with this lab include simple data collection and processing, basic map skills, use of basic statistical tools. And as far as deeper concepts, I wanted to give them an intuitive feel for a best fit line and how far away a standard deviation really is. Now, if you ask your students what a GPS means, they'll most likely think of GPS receiver devices. But I do want them to understand it's not just a tool that tells them how to get somewhere. It's really lots of satellites and ground stations all working together to tell your device what time it is. And your device takes all this and figures out where it is. In the case of many cell phones, there's no actual GPS inside, and it just makes use of cell phone towers to figure out where it is. What you lose is, by the way, is a little bit of accuracy, but not as much as you might think, and you lose the elevation data, but we're going to put that back in when we process the data. Prior to lab day, I give them instructions for both Apple and Android users. I double check that the software I want them to use is still available to download, or I pick new suggestions for them. I only suggest apps that are free, don't require any login, and allow them to easily export GPX files that are created. I'm giving more information here on my slides that I intend to read out loud, so that if you want my slides later, you can download them and follow the instructions. You can also email me if you decide to try this out and get stuck on anything. These are my favorite GPS apps. Apple instructions on the left, Android instructions on the right. Here is another Apple option in case somebody doesn't have much space on their phone. They don't seem to have much trouble downloading and installing software on their phones. The only problem I ran across is a student whose mom was logged in and the student didn't know the mom's password. I have them go outside, make sure they have a signal, and then walk along in a straight line collecting at least 50 data points. It's okay if it's a bit less than that, but if they walk around at least 2 or 3 minutes, they should have enough data. If they stand still, the software won't collect data. So that's just a warning point. Here are detailed instructions, iPhone on the left, Android on the right. Most students are fine with that, but then some have issues with the email. It varies by student. It usually happens in clusters, and students are good at finding workarounds and sharing those tricks with each other. Big shock to me was the great lengths Apple and even Android will go to try to hide all files from users. Really, each app wants to associate files with specific software, and thus the operating system does not like to have floating files. And so when they try to download the file, the computer will yell at them because there's no application that can read the file, and it tries to make you go to the store and find one. Once you convince the computer that no, you really mean to simply download the file, then the browser tries to hide it in some secret download directory that's associated with that browser, so the students have trouble finding it. Once you get past those hurdles, then everything is smooth sailing from there forward. So you upload this GPX file to the GPS visualizer site, and the first thing we're going to do is just sanity check to make sure the data were correctly collected. And so what you should get is first Google yelling at you, so you just ignore that API key error message, and then it will load up into OpenStreetMaps, and it will show you where you walked. And you can tell by looking if this was a good collection. It looks like a path. If you just see like one little spot, then it's not good. Or if nothing shows up, you see a picture of the whole world, then that wasn't a good data collection. Now that you've verified that the data are good, then you re-upload it into the converter, which is on the same website. So you can, again, if you're going to do this, all the instructions are given in detail. Okay, so now you will download that as a CSV file. They've now merged this data with the elevation data, and they've given you speed and distance and lots of other things if you want them. You can ask for heading and stuff like that if you wish. Okay, now you can import this file into any software. Obviously, you're not going to get speed on the first line, but after the first data point, after that it starts calculating the speed. Okay, now you can play around. Notice we say lat long, but in the convention, east-west is actually the x and north-south is latitude. So even though we say lat long, students are going to try to put x as latitude and y as longitude, but you got to get them to reverse that, and then everything will look right on the screen. Okay, so this is the same line that I've been drawing. It just looks funny because StatCrunch chooses its own x and y scales for you. And then this is the regression line. The more advanced skill I did with my students is I wanted them to extrapolate from their line of best fit. I wanted them to go 5 standard deviations away from the mean in the x direction, or that is the longitude. And so then they were supposed to extrapolate a point 5 standard deviations away from that mean. And so unless they walked a very, very straight north-south path, this would result in a point that's about a block away from where they walked, but it was a place they were familiar with. So I wanted to give them an intuitive feel for what it means to be 5 standard deviations away. And that worked out pretty well for most students. Some of them needed help with that step. So what did the students think about the lab? Well, one student, so I've got 6 little responses here for you. One says, I did not think of GPS data this way. I enjoyed doing the lab because it wasn't perfect data. It was data that I collected rather than something manufactured. Another student said, I most enjoyed viewing the path I walked. I thought it was fun and it taught me about tracking paths and linear graphs. And another one was saying they didn't know that the GPS was as accurate as it was, and how much that you could map coordinates directly on Google Maps. Several students said they didn't realize you could just type coordinates into Google Maps. This is like a big thing for them. And so it also improves their navigation skills. People thought, oh, I can do this while I'm hiking or whatever. Students definitely liked creating the data that they would mess around with later. And just, you know, data from their everyday life being incorporated into a lab is really cool. So in conclusion, GPS data is easily obtained by the students. GPX files can be converted to CSV online, and any statistics software can load it and analyze it. Students enjoy collecting the data and analyzing it, and there's more resources if you're interested in trying this out yourself. So if you're going to take a picture of a slide, this is the slide to take a picture of, because then you can download my slides later. Are there any questions?